friends, welcome back to Improve 10x. Knowing is not enough. We should be able to apply whatever we have learned. And when can we apply? Only when we understand the basics along with reasoning. Today we are going to discuss the reasons on why multiple inheritance is not so straightforward in Java. We are going to look into the famous diamond problem. Class level multiple inheritance is not allowed. A Java class can only extend from one superclass directly. This is to avoid ambiguity and the diamond problem. If a class tries to extend from more than one class, the compiler will raise an error. The same can be seen in this slide as well. Let us understand with a real-time example. In this picture, we can see that the mother has high logical skills but low analytical thinking, and the father has high analytical skills but low logical thinking. So, what are the possibilities of the son's logical thinking and analytical skills? Let us see what are the possibilities. So, the son can get both logical and analytical skills as high as possible that matches with their parents. Similarly, the son might also get low logical thinking along with low analytical skills. Also, there is a possibility of high logical thinking but low analytical, and low logical thinking but high analytical skills. So from this image, we can see that there are four outcomes that are possible when it comes to the logical and analytical skills of a child. In this case, the DNA or the genes are taking up the responsibility of deciding the quotient of analytical and logical skills of the child. Similarly, in a software, the outcome must be clearly predictable. In order to program clearly, there is a need for us to understand which properties and behaviors on the class can contain. This enables us to access them without ambiguity. So, in this picture, you can see that there is a method named display in class A. When class B and class C are inheriting from class A, both of them are going to get this display method. So when class D has two parents, which is B and C, then which display method is going to be called? So this is the ambiguity which we are talking about. And that is why multiple inheritance is not possible in Java using classes. Let us see how it works with interfaces. In this particular slide, we can see that interface A has a display method, but it is only the prototype or the signature that is defined in interface A. So when interface B extends from interface A, it is still going to get just the prototype, which is display method. Similarly, interface C is also going to get just the display prototype. When interface D is extending from both the interfaces, which are B and C, it will also get the same display method. When the display method is called in D, since there is no implementation that is added in the method, there is no ambiguity at all. So this is how multiple inheritance is possible in Java using interfaces. Let us take an example of Java collections. In Java collections, there is a queue interface. DQ is an interface which extends from queue interface. Similarly, there is also a blocking queue interface which extends from the same queue interface. The blocking DQ is extending from both DQ interface as well as blocking queue interface. So it has two parents. To understand this problem, let us think differently. Let us assume that Q is a class. So here there are multiple methods: add, offer, remove, poll, element, and peek. If there is a class called DQ, which is extending from Q class, then it is going to get all the methods, the same methods. There is also a blocking Q class, which is extending from the same Q class. So automatically, all these methods are available within the blocking Q class also. Also, we have marked this with color coding because they can have their own implementations of these methods. For example, if you are implementing add method in DQ, it can have its own behavior, and the add method in the blocking queue can have its own implementation. So the problem arises when there is a blocking DQ class which is inheriting from both the DQ and blocking queue classes. So let us see what is the problem in this subclass, which is the blocking DQ, because it is extending both the DQ class and also the blocking Q class. Usually when the superclass add method is called, should it call the add of DQ or should it call the add of blocking Q? Because in both the classes the implementation is available. So this is the problem we are going to address using interfaces. The same can be understood if we think Q as an interface this time. So all the methods are available only as prototypes or signatures, which are the same: add, offer, remove, poll, element, and peak. And DQ is again an interface which is being extended from the Q interface. Similarly, blocking Q is also an interface that is extending from the Q interface. Now, whenever we say an interface, it does not have its own implementation. So all the methods that are mentioned here, add, offer, remove, poll, element, and peak, do not have their own implementations. That is why when the blocking Q interface is being inherited from both DQ and blocking Q, still we only have prototypes. So from here, we can understand that whenever an add method is called, since the implementation is not available, there is no ambiguity at all. Let us see in Java collections interface, what is the signature? So here you can see that Q is an interface that is extending the collections interface as well. Similarly, we have DQ and blocking Q interfaces, which are extending from Q interface, as you can see in the signature. Now, whenever we have a blocking DQ interface, we have extends keyword that is being followed by both the interfaces. So this is how we are achieving multiple inheritance, because it is extending more than one interface at the same time. And you can see that in the signature, which is public interface blocking DQ, extends both blocking Q as well as DQ. This is the reason why we say that Java supports multiple inheritance using the extends keyword, because it can extend more than one interfaces at the same time. As you can see in this example, blocking DQ interface is extending from both blocking Q and DQ at the same time. As you can see in this example, there is a linked list class which is implementing multiple interfaces: serializable, clonable, iterable, collection, DQ, list, and queue. But it extends only one abstract sequential list class. There is this add method which we can see here, which is provided by the linked list class. This add is a method that is available in the interface collection, in the DQ interface, in the list interface, as well as in the queue interface. However, since the implementation is not available in these interfaces, it is unambiguous. So it overrides only the add, which is in the class abstract list. To summarize this, we can say a class can extend only one class to avoid ambiguity. Interface can extend multiple interfaces using the extend keyword. Because there is no implementation, there is no ambiguity. And then class can implement multiple interfaces. As there is no implementation, again there is no ambiguity here as well. Let us circle back to the image that we have seen in the beginning of the presentation. Here, the son is born with just the prototype, which is the left and right hemispheres of the brain, where he can add his own implementations of his own analytical and logical skills by training himself and learning. If you have any queries, you can add it in the comment section. Okay. Let's catch up in another interesting session in Improve 10x. Thank you.